Hello everyone, and welcome back to Bing 101, Introduction to Bioengineering. Today is the first of 7 lectures where you will be introduced to MATLAB, a software language. Before I get into the meat of the lecture, I wanted to go over some administrative details regarding the MATLAB component of this course. For the MATLAB component, as I just said, there's 7 different lectures. For each lecture, we're going to have one assignment due, and the lectures could be called labs as well. The assignment should be submitted as a document or a PDF file and must include all code, figures, and M files. M files are the type of file that you will be saving your work within the software program MATLAB. And all of this work can be submitted via Blackboard. As always, my office hours are by appointment, so please email me at cburk9@gmu.edu with the course title in the subject line and then your name as well. The requirements for passing this course are that you complete all of the lab assignments, and the prereqs for the MATLAB component are a college level of mathematics and an interest to learn MATLAB. Within the 7 different mini lectures or labs within the MATLAB component of this course, the first, which is today's lecture, is Introduction, Orientation, Scalars, Vectors, Operation, and Visualization. Then we'll get into matrix and scripting. In Lab 3, we'll learn a little bit about programming. Lab 4, we're going to do a little bit of ECG, signal analysis. Lab 5, image analysis. Lab 7, introduce you to toolboxes, simultaneous equation, complex numbers, and complex exponentials. And then in Lab 7, we'll get into the kind of interesting and fun, complicated stuff within MATLAB of specific applications of how we can use MATLAB as a bioengineer to make our life easier. To kind of get started today, the objectives are to show you how to access MATLAB, how to orient yourself within the software, and then to go on and describe how we can make variables, whether those are scalars or vectors, how we can do basic mathematical operations such as adding, subtracting, multiplying, and dividing, and then show you how we can plot our data. So to get started, first you'll need MATLAB. Within Blackboard, I have a lot of information of how you can access MATLAB via the virtual computing lab. So if you look at that document, it should be a great place to get started for accessing MATLAB via the GMU virtual computing lab, which you access with your Patriot Web password and your Mason ID, and basically reserve a license of the MATLAB software for a particular amount of time. So I think you can reserve it for up to 4 hours, and then you can access this remotely without having to purchase the software. Another option is purchasing the student version of the software. This is about $99. And the advantage of this is that, of course, you have it installed on whatever computer you would like, and this student version of the software actually has a little bit more functionality than the software that you can access via the Mason Virtual Computing Lab. Once you have accessed your MATLAB, you can open up the desktop. So let me tell you a little bit about the basics of MATLAB. So MATLAB stands for Matrix Laboratory. Everything within MATLAB is done in the form of vectors and matrices. MATLAB can be thought of as a super powerful graphing calculator. It's very important kind of in a lot of different engineering applications because it lets us perform numerical calculations and visualize our results without the need for complicated and time-consuming programming. MATLAB allows its users to accurately solve problems, produce graphs, and easily produce efficient code. So you can think of MATLAB as a tool to make your life easier. It, as compared to Fortran or C++, it allows us to do kind of complex calculations without developing all of the code ourselves to do this. There's a lot of toolboxes which you can pull code that other people have written to use for your own calculations. To orient yourself, once you open up the MATLAB software, you have a command window which allows the user to enter data in the form of variables and run MATLAB code functions and display results. The kind of double arrow indicates that the command window is in normal mode. If there's a K before that, it means that you're in debugging mode. The command history is a window that shows you what you have done previously. It's helpful if you wanted to kind of copy and paste similar commands to save time. So for example, if you had just run a code that multiplied two numbers divided by a variable and you wanted to repeat this for another set of data, you could just copy and paste the command. The current directory is a quick way to view what you are currently using. So for example, if you currently had open two different matrices that you were manipulating, or even two different images that were saved elsewhere, your current directory would show you all of the current files and variables that you had opened. The workspace browser consists of a set of variables, mostly their arrays, built up during the MATLAB session and stored into memory. So if you said that y equals 2 plus 7, within your workspace browser it would say y equals 9, because that would be what the variable y is saved as. Now to kind of give you a view of what this would look like, shown here is a image of MATLAB where we have the current directory highlighted in green, the workspace in black, the command window in red, and then the command history in blue. And I can give you a little kind of demo. So here I opened up MATLAB on my computer, and you can see in the command window I have this double arrow which is showing that I'm in active mode. And if I wanted to do that y example, I could say y equals 2 plus 7, and then you see y equals 9, and then within the workspace I have my variable y, and it has a value of 9. Something that's helpful is if you go y equals 2 plus 7, and then you do a hashtag after it, or not a hashtag, you do a not a parentheses, you do a semicolon after it, you can store it and your variable is named 9. So just a little helpful trick. Another helpful trick is the help and docs function within MATLAB. So this is the most important function when you're learning MATLAB. So MATLAB has a great help library. So if you ever want to get more information on a function, you just type help and then the name of the function, and that gives you a lot of information related to the function within the MATLAB window. And if you were to type doc and then the name of the function, you would have a second window that would pop up. That would be more a document form of information related to that function. So shown here is an example of what it would look like within the MATLAB window if you typed help and then sine, and it would give you information related to the sinusoidal function. And then the second case would be doc sine, and then a document window would pop up with information related to the sine function. Next, I would like to kind of give you a background on creating scalars and vectors within MATLAB. So to create a variable, simply assign a value to a name. So here we could say x equals 90, and then 90 would be our variable. Alternatively, you could have a string which you would enclose in single quotes, and you could say my string equals hello MATLAB, and then whenever you typed in my string, the value assigned to that would be a string, which would be hello MATLAB. It's important to note when you create a variable, the first character must be a letter. After that, any combinations of letters and numbers or symbols can be used. It's also very important to note that this is case sensitive. So lowercase y is different from capital Y, or lowercase x is different than capital X. And don't use I and j when you're assigning variables, because those are used to indicate complex numbers, or pi, which is used to describe the pi, and also ans is used for answer. So all of these have variables pre-assigned to them within MATLAB. For scalars, a scalar is a quantity like mass and temperature that only has magnitude. A scalar is a 1-by-1 matrix that appears in MATLAB as a single real or complex number. So an example would be the variable a equals 100. This is only a magnitude value, so that's a scalar. You can multiply a scalar by a scalar, such as c equals 1.3 times a, so then c would be equal to 130, and then again, to suppress the output, end the line with a semicolon. This is very useful, especially if you're performing kind of complex calculations. MATLAB variables are arrays of numbers. An array consists of one element called a scalar. For example, x equals 2 has a value of 2, so that's a scalar. More commonly, x will assume a number of values, say from 0 to 5. For example, if we had an array that was 4 elements long, and it was 1 through 5, it would be 1, 2, 3, 4, 5. So that would be 5 numbers long. So shown here is an example of indexing an array A, where A1 would be 13, A2 would be 5, A3 would be 9, and A4 would be 10. Within arrays, there's two types. There's vectors of numbers, and there's matrices of numbers. So we'll talk about vectors of numbers today and save matrices of numbers for the next lecture. So just to give you kind of a review of what a vector is. A vector is a mathematical object that has a given magnitude and direction. A line of a given length and position along a given direction, such as an arrow, is a typical representation of a vector. So again, magnitude and direction. You can easily add two vectors by layering the vectors head to tail in sequence to create a triangle, as shown in this figure. So if we aligned A and B head to tail, then the sum of A and B would be the red arrow, A plus B. The base vector of a rectangular xy coordinate system are given by unit vectors I and j along the directions x and y. So if you look at this figure, we can break the vector f down into its x and y components to represent them mathematically, and then if you were to sum them together, you would get the vector f. So just kind of a review of some things that you probably covered in trigonometry in high school. You can have row vectors and you can have column vectors. So a row vector is a 1 by n matrice, and it appears in MATLAB as a row of real or complex numbers. So an example of a row vector would be shown here. A equals bracket 4, 9, 3, 4, 9. So the brackets are indicating that you are creating a vector. You can separate each element in your vector by either a space or a comma. A column vector is a n by 1 vector, and it appears in MATLAB as a column of real or complex numbers. So for a column vector, you can separate each different element by a semicolon or an enter. So that's how you would create a column vector versus a row vector. So let me kind of go through an example of how we do this in MATLAB. So open up the MATLAB window. You can see what we already have in our workspace, and now if we wanted to create a row vector, I'll just say A equals bracket, and we'll do 1 space 2 space 3 space 4 bracket, and you can see that we have a row vector for A. We could do the same thing with A equals bracket 1 semicolon 2 semicolon 3 semicolon 4, and now we have a column vector. So very easy to create both row and column vectors. You can tell the difference between a row and column vector by looking in the workspace, by displaying the variable in the command window, by using a size function to get the vector's length, You can use the length function. Similarly, you can try the size function. So you might read this and say, okay, how do we even find out what is the size function? So if you ever want to learn about a function, again, you go into MATLAB and you say, okay, help size. Whoa, so that brings up a lot of different, a lot of information. So if we read this, it says D equals size of X. So that will tell us the size of our matrices. So let's say X equals size of A. So our matrix A is a 4 by 1. So let's see what A equals. So A was our column vector, so it is 4 rows by 1. So pretty easy to tell the size of A. We could conversely say Y equals length of A, and then you need to spell it right. Y equals G. And you can see that our vector has a length of 4. And next time we will continue with basic math operations within the second mini segment of Lecture 1. Thank you guys for your attention, and I look forward to you tuning in for the next segment.